Hello, everyone. My name is Eduardo Rabello. I'm a solutions architect based in Auckland, New Zealand, and this is From the Field. It's a New Zealand technical show where we bring our solutions architects that work with the customers across the country to share their experience online for us. And here today, I have two special guests coming back to the show with a really hot topic in the market right now. Welcome to the show, Ratan, Vish.
Hi, Eduardo.
Hi, Eduardo. How are you?
Pretty good, thank you. I hope you two are great too. We are on lockdown level 4 here in Auckland, so everyone is isolated in their homes. So that's why I have them in the show live today, so then we can, talk about everything that's been happening in New Zealand. So Ratan, Vish, this is a really hot topic in the market, especially with our customers doing infrastructure as a code here in New Zealand. What we will see here today with pipeline as a code using CDK?
All right, I'll take that question, Eduardo. As you said, it's a pretty important topic for a lot of our customers. Infrastructure as a code is no longer an optional thing. We see, and we're just looking at the ways in which we can make our developers more productive. This is something that has always been our top focus at AWS, and CDK is our attempt to do that. So in this, we will be covering what is CDK, how you use it, and some of the foundational aspects. So I'll do a basic demo showcasing that, how do you use CDK, and then we'll go real deep where Vish actually covers how do you actually build an end-to-end code pipeline using CDK.
Live code today. That's pretty good.
Yeah. So just for the people out there, we'll go from, I would say, right from level 200 all the way to level 400 in today's session. And we're really excited that hopefully this will resonate with you, and you will pick a thing or two from today and start using it in your day-to-day projects.
Absolutely. We are always learning something, right? So every day we pick a trick and tip here and there on a specific article or a blog post. So Vish, from the demo that you built, there's anything specific that we should be paying attention that we will see during this session?
Yes, as I'll be building a pipeline in this demo, and pipeline has some waiting times as and when it goes into deployment stages. So I have pre-recorded my demo. But
Okay.
what I'm going to do is I'll walk you through each and every steps, and I try my lip syncing skills here. Um, so that's one thing. Second thing is I'll be building a Lambda code and API gateway, but I'll be fairly walk you through a bit faster mode, and when we reach the actual pipeline itself, that is where we'll slow down and walk you through line by line how you can build that pipeline, right? So I'll slow down there and basically put more focus on that part rather than focusing on the application itself.
Fantastic. And I know from our previous conversation before we start the show, we have a really special guest here today. Who you are bringing to the show?
Yeah, so we are really, really grateful that the creator of CDK himself is joining the show today. So why don't we bring Elad into the conversation? Uh,
Fantastic. Let me see if here's already. And there we go.
Hey,
Elad, welcome to the show.
hey,
hello,
Elad.
everybody.
Hi,
Great to
lad. Great to have you.
sure.
Yeah, thank you
For having
so
me.
much. Just for everyone, I only reached out to Elad literally 3 days ago. I pinged him, and I wasn't sure that at such short notice he will be able to join. So Elad, I'm super grateful that you have joined us today and to share your knowledge and the whole approach and that how you build CDK and yeah. So we're really really excited to have you. Thank you for joining us.
Cool. Thank you for having me.
So
Cool.
we start the conversation with a fire chat, right, Ratan? So which questions do we have that Elad can help us understand a little bit more the background and the future of CDK?
Yeah, I wish that there was a real fireside chat, happening. But here we are. It's like Twitch fireside. Uh, Elad, I'll just start with real basic thing for everyone out there who is watching the show today. What is AWS CDK really?
So the CDK is a software development framework. It's a library basically for software developers to be able to define cloud infrastructure using normal familiar programming languages. The idea behind it was that this industry of defining infrastructure as code has kind of evolved mostly from like the operational world, and like people installing software on machines, right, in data centers, and like that was basically the evolution of it. And at some point it got to the kind of like this inflection point of complexity. And so if you're using tools like CloudFormation or Terraform or other tools for defining infrastructure using the desired state configuration, you probably already understand why we built the CDK, because as you try to like model complex systems using these configuration files, you basically run into needs that are not easily addressed using these formats, right? Even simple things like an if statement or a simple loop at the if you want to express some business logic that represents your infrastructure on one hand, and on the other hand, the ability to model your system, be able to like describe how your system looks like is usually pretty hard with those tools. And so we looked at these as these existing tools, and we said, hey, we actually have solutions to all these problems. We've been writing software in the past 50 years that's addressing the exact same problems, right? Like creating models, expressing business logic. And so we said, instead of like trying to reinvent the wheel and force this paradigm to like become software, we're just gonna move over to the world of software and enable people to use the tools and or all their skill sets and tools and patterns that are used from software development to express how the infrastructure of their applications looks like. And so this is basically kind of like where we came from in terms of the CDK. And I think the other interesting thing that happens, and that's a very natural kind of evolution of that approach, is that as you move over to, as you have all these like extremely powerful tools for creating abstractions and defining business logic, then you start creating, then you basically start going up the stack in terms of like abstraction level. And that's where the CDK becomes super interesting in my mind.
Nice, nice. Yeah, I really think that that's a game changer aspect of CDK. So, did you have this problem of your own? Were you part of a project team where you were doing your own cloud formation or something, and you felt the need to build this?
Yeah. Actually, that was the kind of like the story behind the birth of the CDK. It was
Wow, story time. Tell us the story.
It's actually a very classic Amazon story, and I think like it's a really beautiful example in my mind is like the innovation culture at Amazon. We've been working in a product that kind of like the serverless system, event based, Kinesis, all the good stuff, large scale Amazon style, and deployed to multiple regions, multiple environments. And as we were like designing the system and created the CloudFormation templates for them, we realized it's like we don't have the right tools to do that. Like copying and pasting CloudFormation templates is not what we learned as software engineers. Right? Like this should.
I still have scars over here.
Yeah, exactly. It's like one of those things that smells bad, and you're like, okay, shouldn't be what I'm doing. And so we started like basically hacking on some internal tool for generating CloudFormation. And there were like also open source projects like sorry, I can't remember the one.
JAWS, serverless framework.
Yeah, I mean there were some external really nice open source projects for like generating CloudFormation from code, and so but I think like the interesting part again was this idea of being able to create abstractions, because one of the things that we really needed is to split the work in the team to multiple people, and every person was responsible for a different part of the system. And we wanted that part of the system to be isolated and tested in, as its own, and then integrated together to form the bigger system, and then deployed into multiple environments. And so like this type of activity, which is very, very common in software development, right? Like when you develop software, this is how you work. We needed the ability to do that with our infrastructure. And so we literally created this internal tool, and it was really a game changer for our team. Like it worked very well. It was easy for like junior engineers to understand it. It was like, it had a lot of good smell in that sense. And then after we launched the system, it was like ahead of schedule. It was like a nice showcase of like these ideas. We went over and wrote this thing at Amazon called press release. I don't know if of course you're familiar with it, but I don't know if everybody's familiar with it, which is this beautiful format for describing the future. So you're basically writing this one-page document that basically tells the story of your launch in 2 years, 3 years, right? Like you're basically kind of dreaming. And it's a really fun thing to do. And so like writing is like Amazon, reinvent 2020, whatever, 2018, I think it was, launches this product. We didn't have that name yet. And so like describing how this would work for customers. And it was really a good kind of, we were at the right time, the right place. There was some interest in like solving that problem, but no existing solution. And so like when we brought this like internal tool to the leadership, and we're like, look at all these examples, right? Like, and we were literally just like walking through the code base in the PR FAQ meeting to show real world usage. And it was easy, right? It was really easy. Like everybody was like, yeah, this looks like it's really solving a real problem for you. It's clear how it can solve problems for customers. And then we started the journey, and it took probably 2 years from that point to like actually release the CDK in GA, which was I think a year and a half more than I wanted. I was like, yeah, we're just gonna release this in 6 months, and then like it took 2 years. So yeah, that's the story.
Wow, that's such an inspirational story, really. You know, having a problem and then solving it at a scale for our customers is truly AWS way and Amazon way. So really inspiring.
Yeah, and
Um,
not only the story about CDK, but how the process also helped have the idea spread across the company, right? And have the opportunity to innovate in behalf of your our internal team and also to our customers, which is beautiful. Yeah.
I think the
cool.
other interesting property that we have internally, and I know that many companies don't work like that, and which is completely, actually something that we're tackling nowadays. But at Amazon, there's no separation between ops and dev. Like the team that develops the software also operates it. Like there's no even like role separations. Like the software developer is responsible to maintain, to provision and maintain and operate their system. And so I think that was another reason why we, there was this connection, right, between the world of
Yes.
ops and the world of application development, because we were like the same people, right?
Yeah, so those small two pizza teams focusing on a single feature, working as a team and look after the entire feature from end to end, from development to release, operations, everything will be looked after by the same team, right? Yeah.
Yeah.
So
I think you have some issue with your
with the
audio.
audio, yeah, Vish. You're a little bit robotic, but yeah, we could get it. So, Elad, we got a question before we jump on the presentation from our viewers. So, how enthusiastic was the leadership from the get go? Was it a huge sell from the beginning, or just after the PR FAQ?
I'm not sure I understand what does it mean, a huge sell? Maybe but I think leadership, like generally leadership at Amazon, is driven by customer feedback mostly. And so initially they were like, yeah, this looks nice. It seems like it solved your problem. I can see how it can solve other people's problem. But let's see how it works. And so like we got some small funding to get started, and we started the ball rolling, and like the Amazon has a very, very strong kind of bias for action culture. Is like release it, put it in the market, and especially in open source, and CDK is an open source project. It's also kind of aligned with how open source works, right? Like you put something that's very early, that's very kind of even experimental initially, and then you slowly mature it and bake it with customer feedback and customer inputs. And in that sense, it was a nice kind of organic growth. And I think the other thing that happened at some point actually didn't happen from the first from day one, was there was some point in time where we collaborated with an internal team, with an internal kind of platform team, to build a CDK construct for the Amazon deployment system, the internal, the deployment system that's used across all of Amazon. And that was kind of like the killer app for internal adoption. And so once that was released, we started seeing like thousands of Amazon teams adopt the CDK, because they really needed that capability, and the CDK offered a really good experience, and it was like a really good alignment there. And so that was another way for us to like see this feedback loop, right? And as the feedback grows, and as we see more customers using it, and then leadership is more enthusiastic. So it's very much like trying to align to.
Working together, right? Cool.
Nice.
And
I think Vish, go for
one
it.
question, one quick question. So some of my customers already use CloudFormation, but they are exploring the ways to go into CDK, and they see the value in it. So what is your advice in converting those existing CloudFormations into CDK, so that they have a single CDK repository where they can manage?
So first of all, there's some good content out there that talks about migration from CloudFormation. I think One of our team members wrote a blog post about this, I think a year ago or something, as we released CloudFormation Include, which is, but generally speaking, I would say first thing you could do, and it's almost like a super low-hanging fruit, is use this construct called CloudFormation Include to include CloudFormation templates into your CDK application. So you basically kind of import the template as is into your CDK application. It doesn't mean that your template now is written in code, but it means it's part of your CDK application. So it's kind of like becomes this first-class citizen. And you can even edit it in your code. So you can like import it into your code, and then you can say add this property to this resource, get this attribute from this resource. You can like start to interact with it in a sense. And so I would say the first thing you could do is use these CloudFormation includes, and then additional resources and additional infrastructure use proper CDK in a sense. So you kind of get this hybrid model. And then what I would do is I basically migrate in parts. I would basically say, okay, let's take this, these bunch of resources. Maybe they're not like stateful resources or persistent data or stuff like that, and I can like start to migrate them from CloudFormation to become CDK code. And the reason I'm saying I would do this manually is because CDK has this concept of levels of abstraction. And we call them L1, L2, and then LN or L3. And
Sky's the limit.
yeah, but at the lower levels, L1 corresponds one-to-one with the CloudFormation spec, the CloudFormation resources. And so in a sense, you're not getting an abstraction. You're basically just getting support for writing CloudFormation. So in a sense, it's kind of like a CloudFormation generator at that level. But the complexity of using, AWS and integrating between resources and IAM and all of that stuff is still there. You still need to understand all the details of how those resources work, how every property works, and so in that sense, you're still at the very kind of like very low level or the lowest level that you can get. And then what we have in the CDK, which is I think one of the biggest, where we inject most of our effort and most of the value, is what we call the L2 constructs. And those L2 constructs also correspond to AWS resources. So you have an L2 construct for bucket and an L2 construct for SNS topics and L2 construct for Lambda functions. But the APIs are higher level. The APIs are intent-based, we call them. So you basically express your intent using object-oriented APIs as opposed to properties, declarative properties. So you're saying, for example, I want to connect this SQS queue to my Lambda function. You say lambda.addEventSource queue. And as you write this one line of code, the L2 constructs will interact with each other, define the IAM policy for the Lambda function and the resource policy for the queue and the event source and all that magic, all these like undifferentiated details are going to be implemented for you. And so when I'm proposing to people to like write CDK, I'm saying this is where you're going to get the most value. And so if you're migrating from existing CloudFormation, the only real way for you to actually go up the layers is to write your code again through the CDK. So I think like that kind of migration is.
And the same defaults from the constructs L2 really helps too. When you are migrating from CloudFront or starting from scratch, there's same defaults following some really good principles, less privileged, all baked in for you on the L2 construct. And that really helps to speed up the agility of the software development and the infrastructure development, which is great for everyone. So yeah, the community can contribute. Some ideas came from AWS and how we work with our customers, but it's open to everyone to put their ideas over there.
Yeah, well, sometimes we like to think about the L2 layer as like an implementation of the AWS documentation in code.
Interesting.
Basically, all the AWS documentation of how to use a service is now implemented for you in code, expressed really nice with nice APIs on top of it. And so when we build these L2s, sometimes we're frustrated. We're like, oh my God, just doing this simple task requires so much details and so many like loosely coupled
Yeah.
strings that have to match with each other, and like, but then we always tell ourselves, okay, this is the last time someone needs to read this doc. Right? It's always encouraging for us.
Nice,
Yeah.
nice
So,
work.
Elad,
So,
sorry, Ratan, just to be mindful of the time. So, we do have a last question here from the viewers. After a few years of CDK running, if you could change one thing in CDK today, what that would be?
nice
Hmm.
question.
I need to
That's
think
a
about.
tricky one.
I think one of the interesting things that we're still struggling with in the CDK is streamlining the connection between the runtime code and the infrastructure code, right? Like, because one of the value propositions of the CDK is you're going to be able to use the same programming language when you write your runtime code and your infrastructure. And that's huge. I think many customers love that about the CDK. And one of the reasons we're shipping the CDK to multiple programming languages like Java and Python and .NET, and some of those languages are like very far from like the ops and DevOps world. And the reason is that we wanted application developers to feel comfortable, right? And that was one of the reasons we have those languages supported. And the thing that I think I wish we would do better, we're definitely in that trying to do better, is to improve the connection between the two phases of execution. If you think about it, right? Like there's basically the phase of execution that defines your infrastructure, and the phase of execution that's actually running as your system is
Your source, yeah,
executing.
yeah.
And these connections are still pretty weak. They require quite a lot of like a boilerplate and tweaking and some build tricks, and some languages that are easier, some languages that are almost impossible, and so I feel like that's the thing that I feel like we should have invested in more from the get go.
Hmm.
But it's actually not a simple problem. Like we don't really have still a clear way to do that. So
Yeah,
that's
but improvements are coming for sure, and I think CDK is paving the way for that to happen and have a unified, uh, at least framework for infrastructure as a code in the future. I love it, so I'm a big fan. So
glad to hear.
Yeah. All right. Hey, thank you, Elad. I wish that we could continue to have this virtual fireside chat. I love it, and all the great insights that we're getting from you. Hopefully, we can probably do another show where we can have you for a longer time. I know you've got a busy day ahead of you. So once again, thank you so much for taking time and joining us. All the way from Israel. Really, really appreciate it.
All the way. I came all the way to New Zealand.
Yeah.
more than welcome.
Yeah, thank you, Elad.
Would have loved to come to New Zealand. Actually, it's such a beautiful place. So thanks for having me, and I'll stay tuned. I'll catch up on the show.
Fantastic.
Thank
Thank you.
Thank you,
Thank
Elad.
you.
Cheers.
Take care.
Bye.
Cheers.
All right, guys, that was amazing, wasn't it? I mean, having a chance to actually ask questions, from someone who created it, and we could get into the story of how did he go about creating it. So, Eduardo, I hope my screen is visible now.
It is. We have the slides over here, a cloud development kit, and some logos, Python,
Cool.
JavaScript. Yep.
So I believe that Elad has already covered quite a lot of it, which is fantastic. So I just want to quickly go over a few slides before we get into a live demo of actually building a simple CDK app, very, very basic. Before, as I said earlier, before Vish goes into the details and advanced topics of creating a pipeline as a code using CDK. So yeah, as Elad mentioned, CDK allows you to define your cloud infrastructure using one of your favorite programming languages, Python, JavaScript, TypeScript, whichever you like, you use that. And support for Golang is coming pretty soon. So under the hood, if you look into CDK, every app that you build in CDK is made up of multiple stacks, one or more. Each stack is really, you can link it directly to, say, a CloudFormation stack. And every stack has got one or more AWS resources. And the second thing that CDK provides you is a CLI, which you use to bootstrap a basic project, and do your synthesizing of your code into a CloudFormation template, and finally do deployments and those things. And we'll look into that very soon. And finally, this is where the magic of CDK lies, as Elad was touching on, that we provide you a set of construct libraries which has got, either you can use, have got one-to-one mapping. If you are comfortable using CloudFormation and just want to use those, you can use what we call L1 constructs. Or if you want to have, where we have automated few of these things with some best practice defaults, you can use L2 constructs. And then we have got L3 constructs, which is really where you have got what we call cloud patterns, which are combination of multiple AWS services stitched together in a best practice way. So I don't have too many slides, and this is probably, after this, I've got a few more slides, but let's get into the demo. So I will switch to my terminal, and what I'll want to show here is I haven't got anything in this directory at the moment. I want to create a simple CDK project. But before I start creating a simple CDK project, let's have a quick look at how do you get started with a CDK, So if you go look for AWS CDK documentation, you'll find this page, which nicely talks through that. How do you get started with a CDK app? Some of the prerequisites that you need to have, how to configure your AWS CLI, and the main thing is what command do you run to get CDK installed on your machine. So I'll just use that. I do have CDK already installed, but I'll still just show you that how do we get CDK on the machine. So I put my password. And yeah, so that's pretty much all we need to have in terms of CDK. And I'm skipping a step which we'll go through in his demo later on. So once I've got AWS CDK installed, I'm actually good to go to set up a first project. So let me do that by just saying CDK init, and then I can specify the language of my choice. It could be Python, or it could be TypeScript, which is what I want to use today. So while this is happening, it may take about a minute or so. You can see in the left side, we have got the project structure coming, a base setup. And while that is happening, I just want to quickly touch on a few of the common commands that we will be using as we interact with CDK. So the first is CDK synth, which converts your code into a CloudFormation template. CDK diff helps you see the difference between multiple deployments, and then you use CDK deploy to basically deploy your code to your AWS account. So once I've got my project set up, and before I look into the actual setup of my project, I know that for my project, I'll be needing few of the construct packages that, so I'll quickly add them into my project so that I have them ready when I start to actually create them, create my application. So I need AWS EC2, I need another one, AWS ECS, and there's one more that I need for AWS ECS patterns. And I can show you where to go to find a catalog of these, what we call constructs. So So while that is happening, let me quickly go to where we find the documentation for these constructs. So we have got an API documentation for AWS CDK, which which provides you all the list of different constructs that are available and what they do. There's another place where you can actually find this is this one, which we call Construct Hub. So here you can just type, construct name, and then you can search through this. Pretty handy to actually find the constructs and the documentation and some code snippets that you can then use in your code. So let's say if I look for ECS patterns, I can find one here which shows me that what it does once it loads. So you can use this, or you can go to Construct Hub and find the details. Either will work. So hopefully all the packages that I needed is here. So I'm good to go. So let me show you what's the basic CDK code structure or project structure looks like. So the bin folder is where you have got CDK demo.typescript. This is the entry point for your project, really. And as I was showing earlier in my PowerPoint deck, that the parent is a CDK app, and then inside that we've got multiple stacks. So this is the place where you can actually inject multiple stacks. So for now, I've got just one stack, CDK demo stack, which comes from this lib folder. And it just provides me some documentation or a help text to suggesting that, hey, which account do I want to deploy this stack in? So I'll take all of that help text out. I can specify these accounts, or if I don't specify anything, it's just going to take the account details from my profile, But for the sake of just specifying it, I'll just be prescriptive and say that, hey, use the accounts, which is a default account for the CDK. So that's pretty much what I need to do. So as I say, it's an app, CDK app. It has got a single stack at the moment, which is going to be deploying to one of my accounts that I have got set up. And now let's look into the place where we will be actually doing the coding. And looks like one of the packages that I've tried to install hasn't. Looks that's okay. So this is where we will be coding most of our things. So our actual application will go here. I will start. Let's say this is where I want to create a VPC first. So I will add one of my package, which is this one. I know that VPC construct is available in that package. So I'll say my VPC equal to, I'll just instantiate an object of that. So as Elad was saying earlier, you can either use a low-level construct, which starts with CFN. So CFN VPC, which is just going to create a single VPC resource and nothing else, right? So that's for creating a VPC. Every construct that we use in CDK takes 3 arguments pretty much. So the first one, as it shows me here, that it is asking me what's the scope of this, which is really what's the parent of this, which stack this resource belongs to. And in most cases, this is going to be referring to the parent in which it's running. So I'll use this. Then it asks me the identifier for it. So it's just a logical identifier. I'll say it's my dev VPC. And then, the beautiful part of this is, look at this. If I'm not providing one of the required parameter for this, it's asking me, it's highlighting that, hey, I've got a problem here. And if I hover over it, it says that an argument for props was not provided. So this is where you provide all the additional parameters that this construct requires to synthesize a CloudFormation out of this code. And I can do these control space to see that what are the other props that it actually needs. So anything which is a question mark, these are optional props. I don't need to specify them, but it needs a CIDR block. And if you created VPC using CloudFormation, you would know that CIDR block is a required field. So I just need to provide that. So it's just a parameter that it needs to take. And yeah, so once I provided that, it should be happy with it. Yeah, I'm finding something unusual here. Which do you have an idea that what's going on here? Is my CDK not set up properly? AWS CDK core is not there.
Could be
So
could be the VS Code itself written. So sometimes when you install a new package, you need to reopen the file, so then VS Code can load the packages. So it could
okay,
be
let me
that.
do that. No, it usually has been pretty good with that. So yeah, so something interesting going there. Let me try putting that package. Hopefully that should fix it. Anyway, so that's how you actually add a VPC. And if my CDK synth runs, let's try that. Yeah, seems to be okay with that. Perfect. So once I do CDK synth, which is converting this code into a CloudFormation template, I go into CDK out folder, and I can see that, hey, there's just a single resource that it has created, which is VPC. But this is not a fully functional VPC. If you've set up a VPC, you would know that we need multiple subnets, you need internet gateway, route table, all of those 20 different things that you have to really do to have a fully functional VPC ready for you. So how do we do that? And this is where the magic of level 2 constructs comes. So let's try doing the same thing with the level 2 construct. So I'll say my VPC, and this time, instead of using CFN VPC, I'll just use a level 2 construct, which is VPC. And same goes here. I need to provide the scope, then a logical identifier for it, and that's all this one needs. So the magic of this is that it has got quite a lot of defaults embedded into it. So I don't have to provide any props. And this time, let's say if I do a CDK synth, and look into the code that it has generated, as you can see that it is now using a default /16 range. It has created me a subnet, which is on /19 range. It's a public subnet. It has set up the route table accordingly, and so on. So I won't go into the details of everything, but as you can see that it has generated 626 lines of a nicely formatted CloudFormation template for me. How cool is that?
And that speeds a lot to the development, right?
Yeah. With a single line of code. And this is where the magic comes. You might be thinking, all the network folks out there, that, hey, but I don't need 10.0/16 range. I want a very specific CIDR range that is available or that has been allocated for this VPC. Cool, sure. So how about we just provide some props here? And one of the props that it takes is CIDR. So I can say that, okay, CIDR, if you want to change, here you go, you use /19 range, and that's it. Then you may have a requirement that, I also want to have a very specific subnet range that I want to use. And this is where some of the amazing power of coding this into higher level language like this comes, is that you're getting autocomplete, you're getting inline documentation. So I don't have to go refer to AWS documentation to understand, hey, what is subnet configuration? I can actually look at this parameter, this props, and it says that, subnet configuration allows me to provide the CIDR range and those things. And here's also an example. So how about I just copy paste this example, because I do want, say, multiple subnets. I want a /24 subnet, and which is for public subnet. I want a private subnet and a subnet for my database. And then I can decide that I want to change this name. So I'll say that this is my web subnet, this is my app, and this is my database. A very standard 3-tier, architecture and a VPC for that. And guess what? I am all set to actually have a fully functional VPC, the cloud formation for that generated with different zoning, all of that done for me with few lines of code. So as you can see now, if I scroll all the way up, I have got /16 range for 10.19. My subnets are on /24. It's a web subnet, and so on. So it's all done for me with literally 5 lines of code, with the ability to actually go and check the inline documentation, have autocomplete, and any of those errors that I was getting. So I'll stop here from a CDK high-level demo perspective, because Vish is going to go drill into a lot of code as we go through how do we create a code pipeline. But again, just basic structure is you have got a bin folder where your primary app or application sits. This is the entry point. Then all your stacks are inside a lib folder. It doesn't have to be in lib, but that's how the project gets structured by default. You can move it around. And cdk.out is where you see all the cloud formation that CDK generates for you. So I'll switch back.
Quick question before we move on. So yes, we saw how we can create a new VPC using CDK, right? Suppose in my environment, if I have a VPC already present, can I refer that as part of the CDK? But that's as a developer, most of the times VPC is already created by, say, my network team. And how can I then use that as a reference?
Yeah, so there is a construct which allows you to do a VPC lookup on the basis of some tags or by a name. So you can use that construct to get a specific VPC and then use that into your project. So so that would be a way to do that. Does that answer your question? Yeah?
Yep. So that's just possible and easy to do it. Yep.
Absolutely possible. I mean, as you asked me this question, I just wanted to quickly touch on that. I did import one of the other package, which was for ECS, so let me quickly touch on this, that if I want to create an ECS cluster, and those of you who are not familiar with ECS, it's one of our container orchestration platforms. And let's say I want to create a cluster of an ECS cluster, and I want to refer my VPC in that. So for that, all that I need to do is similar stuff that what we have done with the VPC. In this case, we will be using ECS, and then I call the cluster. And this is again another L2 construct that we have got available. So same thing goes here. This is my dev cluster, let's say, and one of the props that it needs is that, hey, which VPC it belongs to. So if I check all the other parameters that this needs, I can say VPC, and then very simply just refer the VPC that I've created up. That's it. So this way I can basically refer the resources that were created before into my other constructs. Cool. So that's really the CDK demo part. As we have been showing you, and hopefully we have shown you that CDK is really a game changer. And not because of some of these capabilities that we have been touching on, that, hey, inline documentation, autocomplete, ability to write this into your favorite programming language. I mean, that's really a cool aspect. But the biggest differentiator that we see is the ability that you can create your own abstractions. And why I think that's such a game changer is, having worked in many large enterprise organizations, I see that one of the ways that many organizations try to achieve their compliance or standards across the board is document what they call cloud patterns or best practices in a wiki document or somewhere. And the adoption of that is generally poor, I've seen. And reason being is that, hey, you're asking developers and all these guys who are time poor to just go on a wiki document and then follow a set of instructions manually. How about if we enable them to have all of these approved ways of doing things or building an application through a code package that they can just import into the project? How about if they get a bunch of approved libraries that are available to them that they can just add into their project, and as long as they're following or using those, it's an easy approval process or easy way to meet the compliance need. This is what constructs library provides you, that not only you can just use a set of constructs that AWS is giving you, however, your organizations can create your own construct on top of it with your own internal best practices. Or you can create an L3 pattern which connects multiple services together in a way that's again follows your organizational best practices. So let's say that your organizational best practice is that every S3 bucket must be encrypted. So you can embed that into a construct that you create and then make that available to your developers. So they don't have to follow a manual set of instructions to do that. And the way that we see that this is going to happen is already happening and will happen more of is that with this approach, there will be a central cloud excellence team or architecture team, which is setting up a framework in which people can create these reusable artifacts. And then different applications team can not only use these artifacts, but can also contribute to this. So again, helping grow the developer productivity with the reusability. And this is where the power of CDK lies. And the second thing that I really want to touch on is quite often we see that in organization there is this there exists a silo between different teams doing different things. And sometimes this is by design. The silo exists because the organization is set up in that way, that there is a different team who is responsible for building infrastructure, other one for code, another one for config or creating code pipeline. And if that's by design, I'm saying that you can still leverage CDK and you can make the most of it absolutely fine. However, if this silo exists because these teams use different tooling and different processes to do their things, like if the infrastructure team is familiar with CloudFormation and that's the only thing that they can use, or if your development team are only familiar with Python or TypeScript and they don't want to necessarily learn a declarative language, JSON or YAML, and if that is the reason, what CDK enables you is that bring this all under a single roof, where the whole entire delivery cycle of your project is managed through CDK. So same tooling, same coding language, and breaking those silos. And this is quite common. What we see at Amazon, as Elad was touching on, is that we have a concept of what we call a two-pizza size team, where application team, ops team they don't have clearly separated boundaries that they only build the code pipeline and this team only does the infrastructure as a code. Everybody is responsible for every aspect of the application or the service that they are building and maintaining. So that's really what I wanted to cover. So just to summarize, CDK is truly a really powerful tool. I'll say that we have built it with an intention to help developers be more productive. I've personally been in projects where infrastructure automation part especially takes so long that some organizations tend not to invest into infrastructure as a code, which I think is no longer an optional part. This is something that every organization should do, and there are tremendous benefits of actually automating your infrastructure. So go give AWS CDK a try, and we are listening. In terms of provide us feedback, go to our CDK repo, upvote the features that you're looking for, and we'll continually keep evolving it. We don't think that we've got as Elaz was saying, that we've got everything right about it, but we want to make sure that community keeps suggesting the features that they want to see into this, and accordingly we keep evolving this tool. Over to you, Vish.
Hey, thanks, Ratan. Hi, everyone. First of all, if I drop out, apologies, because I'm facing a lot of intermittent issues today. So here, what we're going to do is have a bit more fun. We'll build a continuous delivery of an app by building a pipeline, and let's see how we can deploy a simple application, right? So, Ratan, if you can go to the next slide. Yeah, so what we're going to do is, so what we're going to do is, as part of this demo, I'll be creating a simple calculator application using Lambda and API gateway, and see how we can deploy that application into multiple stages using a code pipeline. And what we're going to do is the entire pipeline itself, we are going to create using CDK, right? And since my demo has multiple deployment stages and it has some waiting times, so I have pre-recorded my video, and I'm going to play that pre-recorded video as part of this session, but I'll try to give that narration and step-by-step configurations, what I'm doing that in this video, and try my luck with my lip syncing. So let's get started. Let's see how we can build a pipeline using CDK. So overall in this demo, I'll be doing 4 main steps. First of all, I'll be creating a new CDK app, as Ratan showed, using CDK initialize command. Then I'll be doing an environment setup using CDK Bootstrap. Again, I'll talk you through each step as we go. Here is an empty folder, nothing in it, right? So we are starting pretty much from the scratch. So what I'm going to do is I'll be initializing my CDK application. Again, I'll be choosing TypeScript as my preferred language here. And as soon as we start initializing, as Ratan said, it'll give us a boilerplate template or a base template for us. As you can see, it creates a bin folder, which is a main entry point for your application. It'll also create a lib folder where typically you create all your stacks. And it also gives you a test folder where you can write your unit test, and it pre-configures unit testing tools like Jest. Again, as a developer, you don't have to stick to the same format. You can change it in an easy way. And if you want to change it, that's where you go into package.json and change those configurations, right? I mean, you go here and change your entry file if you want to. And if you want to use some other unit testing tools like Sinon, Chai, Mocha, just go under scripts and change those settings. So you have that flexibility. It's only that CDK init will give you that starting point. So as part of this demo, what I'm doing is just cleaning out all the tests that come as part of the CDK init, so that we will write everything from the scratch, right? One important thing I'm going to add additionally as part of my CDK application is called new synth style. Okay, so in order to add that, I'm going to open cdk.json file and add a new property. And am I audible still? Hello.
We're still here. Yeah, I can see Ratan. Yep.
Okay.
Go for it.
Video is paused for some reason.
Yeah, it paused a little bit. Maybe some flaky connections over here.
Ratan, you there?
I think we lost him. Let me check. That's what happens with live demo, folks. So yeah, keep with us. Just a minute, and we are back.
Yeah. Ratan, can you hear us?
Yeah, I don't think we'll be back. He- I can't see him online anymore. Yeah, it's frozen for everyone. I can see people commenting on the chat that yeah, I think he lost his connection. Yeah,
Quickly ping him.
Yeah.
he just sent me a message.
Yeah.
What?
Hey
We
guys,
can
can you hear
hear you.
me?
Yeah,
Yeah,
Yeah.
can hear
we
you.
are back. There we go.
Yeah. Sorry. So there was something at my end suddenly. I don't know what happened.
No
No
problem.
worries.
Yeah. Yeah, just as a curiosity, the last few weeks we saw some really strange DDoS attacks on the SAPs in New Zealand. We also saw some connectivity issues during the day, but I hope that's not the same. But yeah, let's go back.
Yeah.
Yeah.
I mean, just today I've been praying so much to the demo god that it's a long demo. Please keep the internet okay. So sorry, there's some glitches, but hopefully we should be fine. Carry on, Vish.
Yeah, sure. So as I was saying, in the cdk.json file, I'll be adding a new property called, I think if you can play a little bit behind, if you bring it a little even further behind, because I think this is the important part, Ratan. Yeah. So what I was saying is, and the video quality is very bad. Maybe it's not streaming that well. Yeah, it's much better now, Ratan. So what I was saying is here, I'm going to add a new property called new synth style, and I'm going to walk you through why I'm adding this. So in CDK, we have two types of templates. One is default, also called as legacy, but it's default today. But there's new template called modern template, and that is going to be, it's under preview at the moment. And in order to use that, that's where we have to add this property, right? And that modern template is required for us to create some of the modern features like creating a code pipeline. And what it allows us to do is, as part of your CDK bootstrap, which I'm going to talk, step you through shortly, it's going to create all the required prerequisites behind the scenes so that CDK can perform that deployment. For example, you might have your container or Docker images. It automatically creates that ECR repository for you. It also creates all the required IAM roles so that CDK can perform those deployments. And as I said, since code pipeline is a new, we have to enable that. Now, once we have done that, next thing is we will be doing what we call CDK bootstrap, right? In order to for us to deploy any CDK app into AWS environment, we have to do this CDK bootstrapping. And this is where CDK will deploy all the prerequisites, all the required resources into the target AWS environment. And one thing to note, this CDK bootstrapping has to be performed between AWS account and a region combination. For example, if I bootstrapped in a AWS Sydney region for an account, and tomorrow if I have to deploy CDK app into Singapore region, I have to do that bootstrapping again in that region. So command is simple. You call CDK bootstrap command, then provide permission. In my case, I'm giving administrator access, but you can pass your own command as well, and specify account and region combination. In my case, I'm not specifying. That's because I'm passing the profile, and it reads from the profile. And giving profile is useful if you have multiple accounts. And I have a demo using multiple accounts today. Hence why I've created profile so that I don't have to remember my secrets and keys. So using profile automatically, you can switch easily between them, right? I'll be executing this command shortly in this video, and I'll show you how that new modern synth style is applied as part of the bootstrapping step, and how the CDK bootstrap also automatically picks that account and region combination for it to deploy those resources. So as you can see, first line, it's saying that, hey, using new style, bootstrapping, that's where it is picking that property that we provided under cdk.json file and applying. And as I said, it's a AWS account and region combination. That's where it is doing that bootstrapping. By the way, all these accounts are deleted. I only created for demo purposes. Now, if I quickly go into my target account and look at the CloudFormation, that is where that CDK Bootstrap will create a stack set called CDK Toolkit, right? And if I go inside that toolkit, stack set under resources, you can see CDK Bootstrap has installed all the prerequisite requirements so that CDK can do its deployment activities later on. So for example, as you can see, it has created a CloudFormation execution role for itself. It will also create a ECR repository or Elastic Container Registry in case if you have Docker images or container images. It will also create a staging bucket or S3 bucket to store artifacts, as well as it will create all the required bucket policies. So at the end, it will create everything it requires. So the CDK is ready to go ahead and deploy its resources, right? There you go, we completed. It's going to take typically a minute and a half.
One question, Vish.
Yeah.
Do we have to do CDK for all CDK projects? Bootstrapping for all CDK projects?
Yeah, good question. Not required. So you have to do CDK bootstrapping only when your CDK app, maybe you can pause a video. So you need to do CDK bootstrapping only when your application has some asset code. For example, in my case, I might have a Lambda code, or I might write some other asset code where I'll be putting some of the resources into S3 bucket, or I might have a container images to run Kubernetes or maybe containers on ECS. Then only we need to do the CDK bootstrapping. But if you have only the schema, for example, in your earlier case where you created a VPC, which does not have any asset code, and in that case, you don't have to do CDK bootstrapping.
Got it. Okay, cool. Thank you, Vish.
Yeah. And as a next step, as Ratan said, pretty much all resources has equivalent CDK constructs, and I'm installing them. For example, pipeline, Lambda, and API gateway, which I'm going to use to build my project so that it's there for me to use later on, right? So as we saw, step number one, we created a simple CDK initialization to create a CDK app. We did a bootstrap on CDK. Remember, CDK bootstrapping is account and region combination, right? Now here I'm going to rush a bit faster because I think viewers are not that keen on seeing Lambda code, but focus is on pipeline. So this is where I'm creating a Lambda code. It's a Node.js Lambda called calculator app, where it takes certain parameters and send the result based on an operator parameter, right? And I'm also adding a unit test here just to show best practices when it comes to development. So whatever you write, typically you have to write a unit test as a best practice, right? So I'm quickly bringing few unit tests, and the reason I'm writing here so that I can build a nice story later on when I create stack, right? So just ignore it at the moment. So in this step, we created a Lambda, a simple calculator Lambda, and wrote unit tests. Now we need to create a stack. As Ratan said, a CDK will have one or more stacks, right? And typically you need to create separate stacks for a different intent. In my case, I'll be creating an application stack to deploy my Lambda and API gateway at this step. But later on, I'll use another stack to create my pipeline itself so that you have nice segregation of stacks. And as I said, you typically in a boilerplate template, you'll create a stack under lib folder, and I'm creating a class called file called calculator application stack. And I'll be copying a few snippets here, and I'll walk you through what I'm doing here. Right, in this file, first of all, I'm importing all the required packages on the top that I need for Lambda and API gateway and other things on this stack. Created a class called application stack that is inheriting a stack class coming from your CDK core construct, right? And this is where we are creating that CloudFormation stack in CDK. Next thing, we are creating a Lambda function, and we are using their function as a class, which is coming from AWS Lambda construct as I highlighted there. And if you remember, Ratan was mentioning pretty much every CDK class has consistent parameter signatures, right? I mean, scope, or also we call it as parent, ID or name, and you pass the properties, right? Let me elaborate a little bit more on scope. So if you look at CloudFormation, the typical CloudFormation, you have an entire template. Under that, you define a resources tag. Under that, you create individual resources and their properties, right? Basically, it's building a tree. Similarly, that in CDK also, we need to build what we call a construct tree. And in CDK, you will have one or more stacks, and each stack can have multiple resources. That is where you tell, whenever you create any resource here, hey, this resource is part of what stack, so that you can build that tree and CDK understand how to deploy this resource. So in this case, I'm saying that, hey, Lambda, my Lambda function belongs to my application stack that I've created here, which I'm highlighting, so that this stack is responsible for deploying this, right? And second parameter is ID or name. It can be anything. And I just mentioned here calc lambda as the name. And after that, you pass all the required properties for the Lambda function. So for example, I'm saying, hey, for this Lambda, backend code is under app folder that we created earlier. And entry point for my Lambda function is calc lambda.handler. I'm using Node.js 14 version here and specified certain memory size, right? This is how you can create a Lambda in CDK. Similarly, I'll be creating an API gateway. Again, exactly same like Lambda. You use REST API as a class here coming from AWS API gateway construct. Same parameters, you pass the scope. You can name it, pass the name as anything. That you need, it's a string parameter, and specify properties like what is the API name, what is the deployment options, and so on, right? Since I want to use this calculator application, I want to create a method for my API gateway, and that method will call my Lambda as a backend that I've created, right? So here I'm creating a method of type get, and using Lambda integration class, which is coming from AWS API gateway construct, I'm referencing the Lambda function which I've created on the top and saying that, hey, API gateway, this is your backend method, right? And specifying few more templates to pass query string parameters for my calculator, which will not focus that much. But one interesting thing I'm doing here, and I wanted to highlight here, is I am outputting the API gateway URL. Once we create API gateway as part of this stack deployment, I'm outputting that into a CloudFormation, right? So that I can reuse it later. There are multiple advantages. This is how you can share information between stacks. And if you see here, I'm using CFN output, that is level 1 construct coming from CDK, and keeping it in a variable. As I said, advantages is, as in CDK, you'll have multiple stacks, and this is the way you share information among them. Plus, if you're building pipelines, you can use this value to do further processing. For example, doing validation tests and so on. And we're going to see that in action today. Now, one interesting, as I said, I want to follow the development best practices here, and I want to write unit tests for every code that I write, right? And this is where another great advantage of CDK comes into play. So you can write unit tests for your infrastructure as code. I'm a big fan of this, right? You treat development best practices not only for your application code, but also for your infrastructure as code. Right, so I'll be creating a unit test file here called application stack test.ts, and pasting a couple of snippets for my unit test and walk you through that. As I said, it's a game changer, to be honest, because it's not only writing unit tests for your your resources, but also for your entire infrastructure as code. For example, here I'm saying that, hey, my stack should have a Lambda function which should have certain signatures. For example, I'm expecting Node.js 14, for example, a developer should write in this case, and API gateway should have at least one get method here. Imagine you have S3 bucket or DynamoDB, you can test whether encryption is enabled or not. Or you can also bring your organizational policies, for example, vulnerability scanning, static code analysis, all those things you can bring as part of your unit testing so that your developers will get that fast feedback. and your deployments will fail if something is not aligned, or it's not written in certain way that you expect, right? So this is a game changer. And imagine, typically in cloud formation, even though it's a wonderful way of infrastructure as code, but you typically find out errors very late in the stage. But whereas in CDK, you can find out as part of your unit testing as well. Just to demo that, I'm going to break a small signature here. As a developer, I'll be using old version of Node. Like I'll change the version to, let's say, 12 here, then 14, and quickly run npm run test so that I can show you how the unit testing tools will catch those discrepancies, and your build will fail. And exactly same happens when you pass this to a code pipeline, right? And your developers will get that fast feedback. So as you can see, npm run test should fail shortly, and it should say that, hey, expecting is Node.js 14, but you're using a Node.js 12. And it's a simple example, I know that, but you can do a lot of innovation here, bring a lot of policy as code. You can attach that with your unit test and do that next level of automation.
So Vish, this really enables organizations to do what we have been talking about, that compliance as a code.
Exactly.
Right.
You will, developers, nowadays developers, even before putting into AWS, some of the times developers use local Docker containers to build and try out things, and they'll get that fast feedback even before putting that into, let's say, on the cloud, right? So that's how you can utilize those unit tests as part of your continuous governance and continuous compliance.
Nice. Yeah. Cool.
Right. So we completed 3 steps here. We saw how we created a Lambda function in Node.js. We created application stack, and one cool thing we did is we also wrote some unit tests for infrastructure as code. Now let's do a main thing, right? This is where I'm going to go a bit slowly and focus on a bit more detail, right? So this is where we are going to create a pipeline that will allow us to do that continuous delivery, and we'll do that through CDK. And I'll be using the pipeline stack, came under the lib folder, and quickly copy a base snippet with a class, and after that walk you through each line of code. We will be doing even though it's a pre-recorded video, I've done line-by-line coding here so that we can go slowly and walk you through the steps.
Yeah, sorry, Vish, I had a question. So just so that we are all on the same page, so far what you have done is you have actually built your web application, right, which is a calculator app.
Yes.
And now is the main part of the show coming, which is how are we going to actually deploy that using a code pipeline, which is also written in CDK.
Exactly. Pipeline as a code.
Okay.
We saw kind of a policy as code or test as a code. Now we are doing actual pipeline as code, and whatever we built so far, that is Lambda and API gateway, we are going to deploy that using pipeline into different stages.
Nice. Good. I'm following you now.
It's kind of inception, right? So you write code to deploy the same code.
Yeah. So what I'm doing here is just importing all the required packages, and created a class called pipeline.
Vish?
Looks like we have lost Vish.
Yeah, I think we lost him.
I'll pause it.
Let me check if he's on our internal chat. Sorry, folks, we're having a lot of connectivity issues here today. Yeah. Let me see.
This is
unplanned.
Cool, but hey, this is really quite unique. I'm not too familiar with that. How in the cloud formation world developers would write a unit test. Do you know if there is any way that developers could actually do that?
Yeah, from a language point of view, YAML itself doesn't support any test runners. And the benefit of CDK is enabling the ecosystem of the language itself, right? So we go away from a declarative only static language, and we can have either a declarative or a multi-process coding on top of that infrastructure that will be generated. So the ecosystem around the language that you choose can help you define that part. At least from my developer experience, that really helps. So this is what attracts me on CDK. It's because I can use the same skills I have as a developer to infrastructure as a code, which is fantastic. And he's back. There you go. Hey, Vich. Oh, sorry, Vish. Your audio is really bad. Can you try to reconnect? No, yeah, it is really bad. Could you close and come back to the studio?
Yeah, I really think that you may want to try it through your hotspot one time, see if that helps. While you do that, what I'll do, Vish, is maybe I'll just quickly take everyone through what is the whole end-to-end architecture going to look like in the slide deck. Is that okay, Vish? Okay, so while Vish rejoins, I'll just bring the slide deck back. If you can stream my screen, Eduardo.
Yes, we are on. And Vish, if you could reconnect, we will be waiting for you here.
Cool. So as we were talking that we have built this calculator app in CDK. So it's part of the CDK application. The next that what Vish is going to do is build a CDK pipeline, which is going to be another stack. And the CDK pipeline will have, or the code pipeline that we're going to build will have the usual stages, like the source stage, which is to go fetch the source code from code commit here, or you can use GitHub if you use that, and then do a build stage, which is where the CDK is going to synthesize this code and spit out all the CloudFormation templates. And then we'll use that to actually do the actual deployment of the calculator app in one of the staging environment. So first into pre-prod and then into a production environment. So this is the whole end-to-end flow that we are trying to build towards. We're really at a CDK pipeline stage right now.
Hey folks, I'm back. Am I audible?
Way better.
Wow, so cool.
I'm trying my hotspot now. Let's see how it works.
Nice.
Cool.
Okay.
Yeah, the demo is online and it's fine.
Perfect. So what I was saying is, so we will be creating a pipeline. Again, a class called pipeline stack, inherited from a stack class here coming from AWS CDK core. And it's exactly the same code as what we created earlier, right? The application stack. But as part of the pipeline, what we're going to do is first step is to connect to our source repository. And in my case, I'm using code commit, which is Git compliant source code repository from AWS. You can also use GitHub. And you connect pretty much the same way that I'm doing, except that you'll be using different construct. For example, here I'm using repository construct coming from code commit, and I'm saying that, hey, connect to my repo by giving, a scope, a name can be anything, and passing my repository name. And in GitHub, there's one small chain that you have to pass your GitHub access token, and you can keep that access token in AWS Secrets Manager, right? So that's an additional thing you would do. Since I'm using code commit for simplicity, so just directly connecting to that particular repo. Next thing that what I'm going to do is I'll be creating a couple of artifacts or S3 buckets for me to use that as part of the pipeline. And again, I'm using slightly older version of code pipeline here, SDK, or the construct. And if you use the latest one, construct, you don't have to create these artifacts. It's automatically get created by pipeline itself. Now, source artifact is required for code pipeline. Once it connects to your code commit repository, it downloads the source code there so that it can use it for building as part of the build stage, right? And second artifact I'm creating here is Cloud Assembly artifact. This is where once your build step is done, CDK application code is converted into CloudFormation, and it will be stored in this location, as well as your any asset code like Lambda code in my case. So this will be a output folder from where you deploy changes to your target stages or target environments, right? Now here is the actual part where we're going to create a pipeline. So we created all the prerequisites for the pipeline. So I'm just referring here a variable called pipeline and calling a new CDK pipeline class coming from CDK pipelines construct. And signature should be pretty much consistent as we have been talking through these demos. So you pass the parent as a scope, name can be anything, and then you start passing properties for your pipeline, right? Let's see what all the properties we need to pass. So first of all, I will be specifying what is my pipeline name looks like, and this is the name you see in AWS console once it is deployed, and it can be anything. And after that, you will be saying for the pipeline, hey, what is your Cloud Assembly artifact? And that's what we created on line number 16, right? And if you look at the pipeline, typically you'll have 3 stages in a pipeline: a source stage, a build stage, and deploy. As a first pass, let's only focus on source and build. Let's not deploy anything at this point of time. Let's only do a simple things first. So here what I'm doing is creating a source action. That is where my pipeline is going to connect to my repository in code commit. So there is an action called source action, and you say add that and refer code commit source action as a construct, and provide what is your repository and refer that. So here I'm saying that, hey, what is my action name? It can be anything. This is what you see in console, and I'm going to show you that side by side once it is deployed, right? So this is the name of that action. And if you're using GitHub, instead of code commit source action, you'll use GitHub source action, right? And this is where I'm saying, hey, a repository is what we created on line number 12 on the top. Just referencing that and saying that, hey, once pipeline connects to code commit, this is where it's going to download all the files into so that it can use. One more thing, you can also specify a branch. In my case, I'm using master branch, but if you have multiple release branches and you follow that sort of deployment or release cycle, then you can also give a combination of repository and a branch for this. Now, next we are going to create a build stage, right? And for the build stage, again, we have an action called synth action. And you have 2 options here. One is you can use code build construct from CDK and build that code build project by your own. Or CDK pipeline also, has what we call simple synth action. So basically, it's a further abstraction created to simplify and make developers' life easy, so that you have to write less number of code here. So I'm using standard npm synth here because I'm using TypeScript. You can also use Yarn if you're using Yarn in your project. So what it's going to do is, behind the scene, and Eduardo and Ratan, you're going to love this, it creates an entire code build project for you. You just specifying few properties. Behind the scene, it does everything for you in terms of creating build project using AWS code build, right? So as part of this, you're saying, hey, what is my source artifact, where my source files are, and what is my Cloud Assembly artifact, where my output file goes into. And here you can bring your own build spec file, or you can run build command as well. You have flexibility there. You can also bring your custom Docker image if you have, and specify that as part of your build spec file. But for the demo purpose, I'm keeping it simple, just specifying a couple of build commands here, which is npm run build and npm run test. That's it, single line of code there and a couple of properties, and it should create an entire code build project for us. And at this point of time, I'm just committing and pushing all my changes to repository. Right now, one thing to note here is whenever, I mean, I think Ratan already covered this. Whenever we do, we write this application code, you can do that CDK synth so that you can find out if there are any typos or any errors in your code, and you can find it out. And I do that all the time. Right, that tells me if the code is built correctly or not. And if everything goes well, it should show me a CloudFormation template, and also you can show it under cdk.out folder in your local disk, right? And as you can see, already it created around 550 lines of code, and we pretty much wrote 3-4 lines of pipeline code with few properties. Now, one thing to remember here is, even though we are creating a pipeline, pipeline will listen to basically a source repository, right? But our pipeline itself is not deployed yet. So you have to do at least one deployment so that your pipeline is there in the target environment, right? That's what we are doing here. We are saying, hey, CDK, go and deploy my application code into my target AWS environment. And as part of that, it's going to show me what all the changes it's going to deploy there. You can also do CDK diff if you want to find out what is the changes between previous operations and the current one. You can do that. And I'm just saying yes. And this step where I have speed up my video so that I'll cover that 5-6 minutes of deployment times to save some of time to cover as part of this demo, right? So here you go. The pipeline is already created. Everything is green. And that is where we call pipeline as mycal pipeline. And that's what we called in the pipeline name there. We created a couple of stages. First one is source. As you can see, it has created a source stage. It also it's connected to code commit repository that we have specified. And as I said, it also created a build stage, but with simple one line and few properties, it created an entire code build project for us. That means you, as a developer, no need to worry about creating end-to-end build project. And I'm just showing what it has done behind the scene by going into the AWS code build there. And if you look at here, what it has done is it's created a code build. It also executed the command which was specified as part of the build command there. And since it is a CDK app, it also knows that it has to do the CDK synth. Even though we have not specified, it has done by itself. And it created that CloudFormation template, and it puts that CloudFormation template into the Cloud Assembly artifact that we created, right? And it's going to create both CloudFormation template as well as any other asset code. In my case, I have a Lambda code, and in your case, you might have also your container images, and it will store that as part of the Cloud Assembly artifact. Quickly highlight, so we only created 2 stages so far. One is source and build, but it has created a special stage called update pipeline, or also known as self-mutate, right? And this is one of the exciting stage that I wanted to highlight to all the viewers here. So this is a special stage created when you gets created when you create a pipeline using CDK. And what it does is CDK knows that you're creating pipeline through using a code, and the pipeline is going to change. You might add new stages, new actions, and this stage will make sure that your pipeline is automatically updated to reflect those changes. That means your pipeline is self-mutating itself based on a change you make on a pipeline code. So eventually here, to simplify what pipeline is doing, apart from deploying your resources like Lambda and API Gateway that we're going to see shortly, it's also making sure that it stays updated itself. How cool is that? I'm super excited on that particular stage. So what we have seen is we just now created a pipeline using CDK. But if you remember, we just created a source and build stage. We haven't done any deployment. But our ultimate aim of this demo is to deploy that Lambda and API Gateway or our application stack, right? So that's where I'm just referencing here my application stack that I've created earlier, which has my Lambda and API Gateway, right? And as I think as part of the previous talk, Ratan mentioned that some of the best practices where you have multiple stacks in a CDK application, right? And even when you deploy applications across multiple stages like prod or non-prod, even though it is in a same AWS account, it's best practice to deploy that using a separate stack set. CloudFormation stacks, right? So that's where I'm creating here a pipeline stage class, and simple as that, I'm just creating a new instance of application. That means whenever somebody creates a new stage, I'm just giving a new instance of my application stack. That means you're getting new instance of Lambda and API gateway. So we'll see that in action as soon as we deploy. And if you remember, when we created the application stack, we also outputting or giving back the API gateway URL for further processing, right? So here I'm just referencing that and storing it in a variable, and see how we can use that in code pipeline later on, right? Just to summarize, we created here a stage class, and whenever somebody uses the stage class, we are making sure that he or she'll get a new application stack, right? And let's see now, let's work on the deploy stage. As I said, I want to, as part of this demo, I want to deploy into multiple stages. So let me call first stage as non-prod. And simply, I'm creating a new instance of my pipeline stage that created on top, and passing parameters, again, scope as this, and name could be anything. I'm calling this as non-prod. And now I'm saying, hey, pipeline, add a new deployment stage or add a new application stage to a pipeline, right? So I'm saying add application stage and passing that non-prod instance that I've created on the top. Similarly, I can repeat that for the production instance, for example, and say, again, create a new pipeline stage, call it as a prod, and add another stage for my pipeline. So with simple 4 lines of code, we are adding 2 deployment stages using 2 different application stack instances, right? So again, as a developer, I have full control because I'm using my own preferred language here, simplified coding, and you can use all your object-oriented principles here. Now, I want to take this to a little bit further and see how we can add additional actions to a stage. So you can do a lot of, in a stage, you can add more actions. For example, you can write a validation test, you can run some of the shell commands and so on. So let's see how easy it is to create few actions as part of a stage, right? So as a next step, I'm going to demonstrate using a couple of common yet flexible actions. So there are many actions available, by the way, in code pipeline construct. So I'm using a couple of them as part of this demo, right? So here I'm saying that, hey, as part of the stage, add actions. And first action I'm going to use, let me call it as validation test or smoke test. And as a developer, I come across this particular action and I find it very, very useful, called shell script action, right? Very flexible. You can run any shell commands within this with only passing few properties. Behind the scene, it creates again end-to-end complete build project for you. Code build, AWS code build, it'll create, it'll execute those commands, right? And I'll show you how simple it is to run shell scripts using this new action coming from CDK code pipeline, right? So action name can be anything. Again, that will be visible on AWS console once it is deployed. And here I'm showing that how you can read those stack outputs. If you remember, as part of application stack, I'm exporting my API gateway URL, right? So I want to use it later on. This is how you refer that in your pipeline if you want to use it for further processing. So I'm just saying that, hey, pipeline stack output, read from non-prod stage. That's where you have API gateway URL created as part of your non-prod stage. And after that, you can run any commands. And in this case, I'm writing a very simple curl command.
Vish, so this is so it looks like we can actually pass the parameters between stacks.
Exactly. Yeah.
Right.
Yes.
So not only you can structure your CDK application in a way that different stacks are responsible for different things. And then you can pass parameters between them.
Exactly. And best practice is you create stack based on your intent, right? You might have a stack for your web. Let's say you have a web application and you have a monitoring using CloudWatch, you have a backend using DynamoDB, and let's say front end as your S3 bucket and Lambda and API gateway. So you can create one web stack which contains S3 bucket, your Lambda and API gateway, and your database or persistent stack for DynamoDB and monitoring stack for your CloudWatch. Now you have to share some of the information between them, right? And that is how from each stack you can export whatever the information you need, and you can reuse that in other stacks.
Nice, nice. So in complete separation of concerns and
exactly. And here we are taking one step further, that we are reading that stack output within the pipeline, because pipeline is deploying multiple stacks. Now, stacks can share the information, yes, but I also want to use that stack output in my pipeline itself so that I can run some code build project. So here, if you look at the line 59, what I'm saying is, hey, pipeline, read the output from the stage that we deployed. Stage is nothing but a stack created, right? So we created a new application stack part of that stage, and pipeline is reading that API gateway URL, and you can do further processing on that.
Nice. That's super cool.
Yeah, and here I'm running a very simple curl command, and I'm not testing for status code like 200 or something like that. But typically, you would curl against a URL and test for certain status code. But let's keep it simple. I'm directly doing a curl on API gateway URL and saying then it is passed, right? And finally, you have very flexibility here to run actions in different order. So you might have multiple actions within a stage, and you can see in which order you want to execute, right? In here, I'm saying that, hey, run this shell script action once the deployment action is completed, which is once the stack is deployed, right? And I'm going to quickly do the same thing so that I again walk you through that because I'm really passionate about shell script action and the flexibility it brings to the table. So I'm adding again a smoke test or the validation test in production, but this time I'm going to, rather than getting it from the non-prod stage, I'm getting the URL of the API gateway from the prod stage. And that's how you can have multiple stacks going through pipeline, but pipeline is still able to get that output as part of this, right? Right, and I wanted to showcase another thing, right? Another action. So before non-prod and prod, once your non-prod deployment is completed and smoke test is passed, I want to bring the approval gate here and see how easy it is to create an approval action, right? Again, there is a manual approval action available in CDK. And just a couple of properties, it will allow you to have that approval stage. In typical world, you might do it a little bit more in this. You might have SNS topic, sending an email to your QAs, QA team or testers, and they test and approve it. For this demo, I'm using very simple step. I'm going to approve in the console itself. But just to show you how easy it is to inject actions as part of the stages with only a couple of lines of code, right? And again, I'm saying here is hey, run order is after my shell script action. So it waits till shell script is completed and then executes it. So we are pretty much good there. What we have done here is we did a deployment to two stages, non-prod and prod. And we also added a few actions here, like shell script actions for both the stages, as well as we introduced an approval gate between the non-prod and prod, right? And I'm quickly doing a CDK synth again, as I said, so that I can capture any typos, see if my CloudFormation is getting generated. Yes, it is, and we are good to go. And I'm just pushing my code into the repository. Now, if you remember, Eduardo and Ratan, as well as viewers, so we already did a CDK deploy, and our pipeline is already in our target account, right? That means this time, as soon as we do a commit and push to our code repository, pipeline should automatically, start executing, right? Because we already have that hooks between code commit and code pipeline. So if I refresh quickly here, the code pipeline should trigger, there you go, it's already started executing. And I will be speeding up my demo a little bit because it's going to take some time, and come back when we hit that manual approval stage. There you go, our pipeline is created here. And before I walk you through each entire pipeline, what we have done, let me quickly manually approve that gate so that we can start the production deployment. So if you remember, this is a stage we put between non-prod and prod for manual approval, right? So I'm just going to approve that, but then I'll walk you through what has happened as part of the pipeline deployment. Right, so if you look at here, this is where we created we already had a source and build stages. And if you remember, that was a special stage, comes with the CDK pipeline called self-mutate. And as I said earlier, it kind of knows that we have additional stages for non-prod. We added further actions. It automatically self-mutated itself and updated itself to reflect those changes. As you can see there, it has created that non-prod stage that we have specified there, and also it created a deploy stage, which we have specified in line number 53. And it also added our script action, shell script action, which is, we call it a smoke test, which again creates a code build behind the scene. And finally, it also added a manual approval action, which I've just now manually approved a minute ago, right? Similarly, it also identified stages have been added for stages called prod is added with the respective actions, and the pipeline has automatically updated itself to reflect that. So if you look at this, I have not touched anything in console in order to configure my pipeline. Imagine doing this in a console, and we know that pipelines keep changing, right? And you will always modify, add new stages, actions. I have to go always, back to the console, manually configure it, come back. But here, everything is happening automatically, right?
Ratan? I think
Hi,
we
Ratan.
lost him again. Vish?
I think we lost Ratan.
Yeah, he's frozen to me. Let me see on the internal chat here. Yeah, today's been the day, folks. We have been connectivity issues during the whole show. Apologies about that. And yeah, once again,
Ratan, can you hear us?
and he dropped. Okay, let me check on the internal chat. Yep, he's coming back in a few minutes. While we wait for Ratanovic, we do have an interesting question on the chat, and I would throw you under the bus with that. So imagine you are on an interview and someone asks CDK versus Terraform. Which one would you choose, or what are the benefits between one and another? There's support for Terraform and CDK or not? What would be a specific answer to that?
Yeah, so it depends, right? I mean, since I come from a development background, I choose CDK as my personal preference. So both has its own preference. For example, Terraform might be some of the regulated customers might think Terraform gives them the contingency so that they can target multiple different clouds, right? Whereas CDK will allow me to do that, write everything based on language of my preference. And you know what, CDK is, there's a CDK project happening with Terraform as well. So that means there will be a CDK support for Terraform. And once it is there, I was just reading other day an article. Once it is there, that means your CDK becomes like a developer language to build IAC, no matter whether you use CloudFormation under the hood or whether you use Terraform, right? So again, it's a personal choice. If you ask me as a developer, I would love to go with CDK because handling with large YAML files, JSON files is tricky, whereas writing in a language of my choice is much more much more
It's easier.
easier. Yes.
Absolutely. So, from the CDK ecosystem, there anything that besides the CDK pipelines that you have been showing to us right now, anything that people should be paying attention that like is coming up or is under development that you could just drop a hint for them?
Yeah, a lot of, as I said, I mean, I just mentioned I'm using one of the slightly older version of CDK pipeline and when I built the demo, but the new version is
Mhm.
also available. So we are making a lot of improvements where you will further simplify that. As Elad was mentioned as part of his talk that, hey, we want to take away all the behind the scene things and abstract away things. For example, in this case, I was creating source artifact, cloud assembly artifact. You don't have to do that even with the new version. So that
Ah,
means you just express your intent. Hey, I need a pipeline. It should work like this. And behind the scene, it does everything. So I think we are heading in that space. And another thing to look out is level 3 constructs, right? And
mm,
especially I work with a lot of banks and financial services, industry customers.
mhm,
And uh, regulatory requirements is that when they move their high risk workloads into cloud, that has to go through the approval process. And by
right.
having those patterns, first of all, it speed up the development process because you're reusing the patterns created by your either Center of Cloud Excellence or Cloud Foundations teams. So that means you're reusing. But imagine those patterns are already gone through the approval process and checked all the compliance. That
Right.
means from weeks of approval process, you are doing that in minute because it's already approved. And as part of your pipeline, you're using those, level 3 constructs. Again, I'm seeing, since it is an open source community, I could see a lot of innovative level 3 construct is going to come into that area, and you can watch out that area and you can reuse them.
Fantastic, and definitely working with the financial industry, they have a different level of governance, right? And being able to write your infrastructure using a specific language, it helps you integrate that with the wider ecosystem of projects and security, right? What kind of partners are you seeing on the financial industry that they are using CDK for? Is usually like a web app or a back office application or is integration? What is the most common project that they use?
I mean, from my experience, again, from my customer exposure, so a lot of customers using in the microservices world, right? And a lot of even though in the banking industry, a lot of digital transformation is happening, and banks needs to build those loosely coupled components, and microservices are coming really handy in that regard. And they create a smaller teams who are responsible for from implementation to deployment to operations. That's where they are using CDK. And so that is the
Yeah,
one
no,
example I can.
that's great to hear. It's definitely something to keep your eye on, and we are always releasing new patterns on the CDK patterns. So yeah, the hub is already live. You can have a look on that. And we are back. Ratan joined us again. Connectivity issues, mate.
Ah, it's one of those days. I'm sorry, guys.
Yeah, no, it's just fast forward maybe till the end. We are almost there. Right. So here, a quick summary what we have done so far. As Ratan mentioned, if you don't have CDK AWS CDK installed, you need to do that. I didn't do that because it was already installed. Otherwise, Ratan showed how to install that. And once you install, first thing is to create a CDK app using CDK init command. And you can choose a language of your preference, like TypeScript that I have chosen. CDK Bootstrap is very important step, and you perform that with a combination of AWS account and region. And After that, we saw how you can create multiple stacks. We created an application stack to hold a Lambda and API gateway that we wanted to deploy. And finally, we saw how easy it is to create a pipeline using CDK. And we first tried with creating a simple stages like source and build. We saw how you can deploy the CDK application first time so that your pipeline is in the environment. But what we also seen is you can add deployment stages, corresponding actions fairly in a simple manner, right? Using a couple of lines of code. And we also seen flexible actions like shell script action, as well as approval gates like, manual approval action, right? And finally, we saw that once you deploy push your code, how the pipeline automatically self-mutate and does that. There you go. So end-to-end pipeline is green. So here you go. We did a pipeline as code without touching the console, everything from CDK, and it deployed my application into multiple stages. With that, Ratan, over to you.
Great, Wish. So that was a wonderful demo, quite in depth. I mean, I would say that was probably 500 level. Some of that went over my head as well, but perhaps that because it's a great whole lot of detail, and it truly shows the power of CDK there. So the next thing that I believe, if we can share my screen, if I'm still sharing. Let me share my screen as well.
Yeah.
So one of the things that we wanted to do today, which I think, do we still have time, Vish, for showing a multi-account setup?
What do you think?
We have had lots of connectivity challenges today. Because of that, we have obviously run out of time.
Maybe I'll take a minute to talk rather than demo. So, but I think one of the questions might come is if you go into the next slide, this one. So the part of the demo, what we have seen is I deployed multiple stages using a pipeline into a same account, right? But it's also common, and I've seen that in many customer places, that you keep your pipeline in a separate account. They might call as a tooling account, or maybe shared services account, and your non-prod or test accounts are on separate AWS accounts. And a lot of times I get this question, hey, can we do that using CDK pipelines? Absolutely, yes. You can do this. There is no changes, pretty much the same step as I showed already as part of the single account. Only a couple of small changes happens is how you do the CDK bootstrapping. If you remember, we do a CDK bootstrap, provide a account and region, and then provide a permissions, right? So when you do that on, so let's say target deployment accounts, for example, let's say here in the slide, you have a beta account. Mm-hmm.
I'll just quickly bring that slide, the video, so you can just touch on that part. Yeah, that's a really important part. So I'll just touch that if you, because I think that's a very important aspect. So let me do that quickly. Yep. So
right. Yeah, so this is the first account that I have where I want to store the CI/CD pipeline or the tooling or shared services account. And it's pretty much the same as what we did earlier, right? You are saying CDK bootstrap, provide what permission CDK can have. In my case, it's administrator access. Then you're specifying account and region combination. It's same, nothing differs here. But where it differs is on the target accounts where you want to deploy resources. Let's say I'm deploying Lambda and API gateway into prod account, which is separate AWS account, sits outside this DevOps account of mine. That is where a slight change happens, and I'm going to highlight that. So this is where you do the bootstrapping in this fashion. So pretty much the same, and you start with CDK bootstrap. You again provide permissions, provide account and region combination for their prod account. But if you notice in the middle, I am specifying trust to my DevOps account, right? So that is my DevOps account. I'm saying here is, hey, my DevOps account can assume a role and deploy resources into my prod account. Or in other words, CDK is creating a cross-account role here and providing my DevOps account to deploy into the prod account. So that's a subtle change. You have to do it.
Yeah,
as part of the bootstrap.
You in a usual way, if you're not using CDK, for example, you may have to do this manually, right? Creating a cross-account role and everything.
Yes, and if you're doing that in CloudFormation, there are a lot of steps in it.
Yeah. Yeah,
I never
absolutely.
got it, and I never got it working for the first time because I made some one or other mistake when I'm doing referencing, right? Because you have to assume a role and allow other account to assume that role and deploy the resources.
Not to mention the indentation on YAML that and
Oh
sometimes
yeah,
really yeah.
yes,
Yeah.
exactly.
Uh,
So yeah, that's really the main difference, right, between a single account and cross account, which is to make sure that the DevOps account has got right privileges to do the deployment into non-prod as well as prod account.
One another small thing is when you're creating the stage, you pass environment variable. I think you covered that already, Ratan. As part of your entry point bin folder, you pass the environment where you're specifying what is the account and region, right? Similarly,
Yeah,
when you're creating stages within the pipeline, you can specify what is my target account, and that's how you say non-prod stage is going to the non-prod account, and prod stage is going to the prod account.
exactly. Yeah, yeah. So that's
Fantastic. Yeah. Yeah, I
perfect.
think just mindful of time, folks. We are almost closing for 2 hours now. And before we close up, there is anything that both of you would like to share with everyone, like, a heads up or keep an eye on something, so then we can close that nice demo in a really fashion way.
Yeah, I mean, really, what I would like to say that some key takeaways is as we have discussed and shown you that how you can model your infrastructure in one of your familiar languages. So give CDK a try, even if you are a big Terraform or a CloudFormation fan. Just take CDK for a ride, and see that how it fits into your development processes and everything. Vish was showing that one of the coolest thing about CDK is that you can actually do unit test on your infrastructure as a code, which is really incredible. I mean. Third is CDK pipelines allow you to apply the same development principles that you apply to your application code. You can apply the same to your pipeline. So writing in the same language. So what we're trying to bring here is that you're not just writing your infrastructure in the same language as your application code, but your code pipeline is getting built into the same way. And finally, CDK constructs, we have shown you the incredible power that CDK constructs bring in terms of improving your productivity, ensuring that how you can use these reusable components to speed up your infrastructure as a code, as well as create your own reusable components which you can share within your team, within your organization to meet your compliance requirements and those things. So that's really the main four. If we have to say that, what are the key strengths or key takeaways from this session is these four.
And for new
And
Vish,
finally,
oh,
yeah,
sorry, go for it.
go ahead, Vish.
Yeah, pretty much. I second what you said. And plus, come and join us on open source community and help us building new construct. Let's build some innovative level 3, maybe level 4, level 5 construct as well.
No, fantastic. Well, I just need to thank you folks for being with me in the show and also the challenges of connectivity during these 2 hours. But yeah, it was a great presentation. I hope everyone that is watching, picked up one or two tips and tricks from there. The video will be available just after that. And yeah, thank you everyone. Have a good night from New
Thank
Zealand.
you, everyone.
Bye bye,
Thanks,
and see
everyone.
you
Thanks
in a
so
few
Stay
much.
safe.
days.
Cheers. Thank you.
Bye.